Okay. Good morning, good afternoon, everyone. I hope everyone at your end, including you, are safe. On behalf of All India Orchestra Group, I would like to welcome you today for our weekly webinar. And before that, I just want to quickly provide the major web series is coming next month, starting from July 1st. That's Oracle Groundbreaker Yatra, and that's one of the premium one we do normally, face to face and a lot of fun. And Lucas was actually there, couple of yatras, series. But this year, unfortunately, we are doing online. But the good point is, the good thing is, we are able to bring almost 100 plus speakers and from different corner of the world. So it's really good. It's like a 14 days, 125 sessions, I think I have here. Okay. So 14 days, 125 hours of learning and networking. As I mentioned, 100 sessions from 100 speakers and 25 countries. Yeah. And also the major part is 60 plus Oracle ACE community speakers, including ACE directors, ACEs, associates, groundbreakers, and Java champions, and 7 plus hands-on labs, and 5 plus master classes. And we divided this tracks into days. For example, it's July 1st starts with Oracle database, database for DBAs, and then next day goes to database developers. So you can see everything. Let me quickly share the web page so that you're aware of how to navigate. It's very simple. Go to aiog.org. Hope you can see, right? Yeah. AOG.org, and in the homepage itself, you'll find a 12 days agenda. Your job is to just, you can check clicking by one link and who is talking at what time, and you register. So what happens, this year, the whole series is free of cost. You can click here, or you can just do a join us page, and we have a separate box for OG Yatra, which is a free membership, and you are happy to join other memberships and get more benefits. But I think let us focus on the free membership. It takes only 1 minute to fill the form. Why we are pushing, one of the reason is because it's like, if you quickly go through this one, it's like 100 sessions, right? So we want to make your life easier. And once you fill the form and log into this portal, and your job is to say register, right? And once you register and come to this portal again, say join. That's all you need to do. And everything is automated in the background. It automatically registered in the Zoom account, and it comes back, and it will send all the automation. So that's what. And also what happens after the event, right? You want to access files or recordings. So we want to keep everything in one place. And again, this is only for one event, and you can take much more advantages using this portal. We will talk about that, coming webinars, but this is a no, we have, I think, a very less time. So it's starting from next Wednesday. So we have weeks time. Also, we have a limited capacity because Zoom subscription works on number of users. So we are planning to buy a certain number, and hopefully you guys will join in that bracket. Otherwise, you'll be like frustrated, if you're not able to join. So please register, and we keep sending emails to all the registered participants. So please do it. With that, I'm just going back to my slides. I'm going back a little back now. So today we have lucky to have Lucas with us, who will share his insights on Oracle Cloud Native Application Development. And Lucas is our really, really close community friend. He's supported many times to Oracle, All India Oracle Resource Group. He lives in Netherlands. He's the Oracle is Groundbreaker Ambassador, Oracle is Director, and he's everywhere. You ask any technology, he can talk. So very warm welcome, Lucas. Before handing over to Lucas, I would like to remind you a few things. Um, And this webinar is only available in Zoom channel. So if you want to join, if you want to communicate to your friends, ask them to join this Zoom. And the presentation will be shared with all the registered participants after this webinar. And also we'll send you a speaker survey. So please fill that form. It takes less than a minute, and you are able to access the presentation. So at the end of the presentation, please participate in a fun quiz. Not really fun quiz, basically on the today's topic, and one of the participant will get free voucher, right? Also, you can take pictures, and I think we are pushing this very, very important, because this is the only way you can connect to the community. For example, you take a selfie with Lucas today and post it in Twitter. I think I can show you that one. So I'll share the Lucas one. So you can actually search Lucas Jalema in Twitter, and you can tag to him. And what happens? Multiple people also tagging Lucas. That way, who's actually attended today's webinar. That way, you can virtually build your networking, right? So it's very important, right? Uh, so um, so with that, I'm going to hand over to Lucas, and please share your screen, Lucas. Thank you.
I will. Thank you very much for this introduction. And you should now see my screen, hopefully.
Yes,
Okay,
absolutely. Yeah.
good, good. Good afternoon, all of you. It's morning in the Netherlands, but it's only a few hours time difference. This will be a fast ride. I have big ambitions for this session. I'm going to show you cloud native application development on Oracle Cloud Infrastructure, introducing no fewer than 10 different cloud services. All of these services can be used for free in your trial account and for only very limited expenses if you use it outside of that trial account. So you will be able to build software fast, build scalable software, build software in an agile way, and in a very cheap way as well. I'll very briefly introduce myself before going right into the session. As I pointed out, I'm an Oracle Groundbreaker Ambassador ACE Director. I work as a CTO for Amis, a company in the Netherlands, which is part of Conclusion. And when I go to customers, I will call myself Cloud Solution Architect, or any combination of those words. So it could be Solution Architect or just Architect or Cloud Architect, whatever feels best in a certain situation. I'm coming to you from the Netherlands, and most of you probably are currently inside of India. These two images of our countries are not to scale. The Netherlands is so small, it almost fits into Mumbai, and we certainly don't have more people than you have in Mumbai. I was there 2 years ago, as I pointed out, during the last physical yatra that I attended. I was there in 2014 as well. In 2018, I brought my son, and I was happy to have him there, and we had a great time. And I hope to do it again, maybe with my second son, who is also very keen to come to India. Okay, I said cloud native. And what exactly is cloud native, apart from a very nice marketing term? It's used in different situations, but my definition is the one shown on this slide. It's an application that's born in the cloud using technologies that were created in the cloud, or at least for the cloud. And an important part of this is that we are not dealing with infrastructure explicitly. Of course, it's there, but we don't have to know it. We work on a fully managed platform that's very quick to ramp up, that's very scalable, scale up and scale down dynamically as we need. And we pay, of course, per use. As we scale up, we'll pay more. As we scale down, we'll pay less. If we're using only a small fraction, we don't pay at all. And that's all covered by the services I'm talking about today. And then also part of this cloud native application strategy is a high degree of automation, both at the application level and the infrastructure level. In fact, we don't discern all that much any longer between application code and infrastructure and platform as code. is treated in much the same way as our application code is dealt with version control, with Git commit triggered pipelines, etc. So that's our context in terms of cloud native. Now let's look at what we need from a cloud in order to do cloud native application development. What are the cloud capabilities that we require? We want to be able to create functions, serverless functions that perform a certain task, that are instantiated by the platform when the trigger, usually an HTTP request, is happening, that scales to many instances if that need arises, and that will run for only a short period of time. We need an API gateway to make sure that we can get to our functions even from the public internet, but in a safe way. And we'll talk about API gateways in a moment. We need the ability to publish and subscribe to events through event topics, to have decoupled communication between our functions and between our functions and other components. Of course, we need from our cloud the ability to persist data in various ways, structured and non-structured, SQL and NoSQL. We need probably the ability to use a cache, an in-memory cache, for very fast data retrieval, provide functions with state, even though the functions themselves will be stateless. Of course, we need security provisions to protect our application from the public internet and all the dangers lurking on the public internet, and to implement authentication authorization. By the way, we'll discuss security only very briefly in our session today. And we need facilities to perform monitoring. We need to know what's going on. We need to know when to act, when something's going wrong, when there are issues, when we need to scale up or scale down. Ideally, that's done automatically, but we need to be aware. We may need to perform auditing to have a trail of all the actions, either at a functional level or at a more technical level, that take place. And of course, we need cost control. And this is a warning from down at the bottom of a pit in which we fell 2 years ago, where we had a huge overrun of our cloud costs. Was the Oracle Cloud was an overrun of more than 10K. We were not happy, 10K euro that is. And as I mentioned, automation is extremely important for cloud native development. So we need the facilities to apply this automation, as I said, to the application as well as to the infrastructure, the platform and the infrastructure, as we do not really discern between the two. That's what we need. So now let's focus to Oracle and Oracle's cloud. And unfortunately, there are still many people that I encounter that are surprised when I tell them Oracle even has a cloud. It's all AWS, it's all Azure. It's not so much about the Oracle public cloud. That may change, and Oracle's Generation 2 cloud, or the Oracle Cloud Infrastructure, is a pretty decent cloud. In fact, it's a pretty good cloud. The previous attempt, what we now have called Oracle Classic Cloud or Cloud Classic, wasn't all that great. So Oracle basically has two main pillars in its strategy going forward. That's the infrastructure cloud. That's the one we're talking about today. That's where you deploy your own applications. And there are the cloud applications, the SaaS pillar, if you like. That's a completely different story. That pillar is using, to a large degree, the Generation 2 cloud, but other than that, it's largely separate from it. So this Generation 2 cloud has been designed almost entirely from the ground up for the cloud. That's in stark contrast to the classic cloud. That was mainly on-premises software that Oracle was trying to run in its own data centers and providing to customers. That wasn't cloud native at all, and it showed. In Generation 2 cloud, many hard lessons learned are applied, both from Oracle's classic cloud as well as from AWS and Azure. Many people who used to work for AWS and Azure took the opportunity to build an entirely new cloud, benefiting from all their experiences. And of course, that made the Oracle Generation 2 cloud a much better cloud than previous attempts, and to some extent, even than the competition. Oracle also made a number of very focused acquisitions. You see some of the names of those companies on the slide. And with these acquisitions, a number of cloud native facilities could be added to Oracle Cloud Infrastructure. So the main themes for the Generation 2 cloud, as Larry will keep on telling you, it has a very competitive pricing compared to AWS and compared to Azure. And that, of course, is not Oracle's usual tactic, but they need to get market share. It's secure by design. It's open in terms of different open source technologies, but also openness of how to interact with the cloud through the console, but also through other means. It's geared towards the enterprise. It's mature, proven, scalable technology. It's not just for your small applications, but it's also for your small applications. It's also for the startup. You get a 30-day free Oracle Cloud trial with $300 worth of credits that are actually worth much more because you get the cloud services at a huge discount when you're in such a trial. And there's also an always free tier. And in this always free tier, you even get the Autonomous Database, which is the full-fledged Oracle database, or the Autonomous Data Warehouse, which is basically also the full-fledged Oracle database. So this always free tier also has 2 compute VMs in addition to the 2 database instances you get, block object and archive storage, load balancer data. You see it on the slide. It basically means that for no cost at all, you can have applications running all the time. Not very big applications, but still. With the Oracle databases, you get 20 gigabytes of data, which is enough for most do-it-yourself applications, I would think. So we'll talk about a number of different services in the Oracle Cloud Infrastructure. I said 10, maybe even more than 10, but definitely not all of them. Here you see a number of areas where the Oracle Cloud Infrastructure is providing cloud services. And we will look at custom application development services, not so much at the emerging technologies where you'll find blockchain and IoT and analytics and big data. That's outside of today's scope. But there is a lot of additional functionality to be found on Oracle Cloud Infrastructure. And it's everywhere. This map indicates all the data centers, all the regions, as they're called in cloud terminology, that will be available by the end of this calendar year. There's one in Amsterdam. That's nice for me, low latency. And there are also data centers in Mumbai and Hyderabad, which is nice for you in terms of latency. And of course, we can connect all the regions to each other through very high-speed internet backbones. In addition, you'll see the Azure logo on this slide. That's because Oracle and Microsoft have entered a collaboration where in a number of locations, and that number is growing, you will be able to very easily connect Oracle Cloud Services to Azure Cloud Services and vice versa with very low latency between the 2 networks. The companies have recognized that most organizations will have a multi-cloud vendor strategy, and they are catering for that. Okay, the Oracle Cloud Infrastructure Services for Cloud Native Application Development. This is not an exhaustive list, but it's certainly the list that you want to start with. As I said, we need support for functions, and Oracle Cloud Infrastructure has support for serverless functions based on the Project FN framework. More about that in a moment. It also has the API gateway, which allows us to expose our functions in a safe way, in a controlled way, to the public internet. And there is object storage, obviously. There's also a NoSQL database. And there's also the option for streaming. And streaming basically is a decoupled event publish subscribe mechanism, very similar to Kafka, Apache Kafka. In fact, streaming is compatible with Apache Kafka. Functions can publish to a stream, and a stream can trigger a function indirectly, as we'll see in a moment. And then, for example, the digital assistant, which we use to build chatbot or conversational applications, as I should call them, is one example of an application that could benefit from invoking the functions to perform logic and to collect data. Other facilities that you have at your disposal to run your own applications are on Kubernetes. Oracle provides the Oracle Kubernetes engine, which is a managed Kubernetes service for running containers. Also the OCI, the container registry. And of course, you can also just get a compute VM and run your applications inside of that. But then we're sort of getting away from the whole cloud native approach. So better stick with functions. Then there's a number of facilities on OCI that will support us, and we'll talk about the events that you see mentioned here. There are several ways to interact with the cloud platform to create cloud resources, for example. There's the resource manager, there are API services, there's a console. We'll talk about those in a moment. And then there are facilities that help us to perform operations, the cloud operations. We can perform health checks automatically. We can implement monitoring for checking on metrics. And we can also define alarms against those metrics. We can use the logging service to explore our logs in a way that's very similar to the Elastic Stack or Splunk, for example. And we can make use of notifications. And I'll introduce notifications at a later point. Several tools are available for us as developers to work with Oracle Cloud. There's the console, and I will demonstrate the console throughout this presentation. There's also the command line interface, and I will also show you the command line interface. Then there's a number of SDKs in which you can programmatically interact with the Oracle Cloud infrastructure, both for managing cloud resources and for using the cloud resources. And they all work against the REST API. So both the console, the command line interface, and the SDKs under the hood all work with the REST APIs. We can also invoke those REST APIs straight away. And there's a number of tools and plugins available, and this list will continue to grow. I won't go into detail for these tools, but be aware that they exist. And then there's Cloud Shell, and I will show you Cloud Shell in a moment. Cloud Shell is a browser-based tool with a lot of goodies installed that's already configured to work inside your cloud tenancy. So all these tools that you show on the slide are available and will work in the proper context. And I will make use of this in a moment. Okay, today's challenge, my challenge that I'm going to address by building cloud native applications. If you tweet, and Sai already encouraged you to tweet, and if you tweet, you will become part of this session because I'm going to listen to tweets, or my cloud native application is going to listen to tweets. And the challenge I've set myself is that any tweet with AIOUG as hashtag, or AIOUG webinars, as I think Sai showed, AIOUG webinar, trying to remember that one. Any tweet with that hashtag will be processed into a record in an NoSQL database, into a message on a streaming topic, and into an email. That's my challenge. And how am I going to address that challenge using the services on the Oracle Cloud infrastructure? The next slide will be somewhat overwhelming. Here we go. So this is what I'm going to build in order to achieve the functionality I just described. There will be a function that will listen to the tweets. That function can be invoked directly from through API Gateway, or it can be scheduled using a health check. I will talk about that in a moment. The function will write the tweet report as a JSON file on object storage. This will trigger an event. That event will be published to a notification topic. That will be the trigger for an email being sent. It will also be the trigger for another function. This function will read the tweet report from object storage and will then create a record for each tweet in the report in the NoSQL database and publish a message on the streaming topic for each tweet in the report. This is, of course, a very roundabout way for implementing this functionality, but I'm hoping by doing it like this, I can demonstrate the features of all the various cloud services for you. So here basically is some detailed explanation that hopefully make more sense after the presentation is complete, and the slides, of course, will be available. Okay, let's first focus on the serverless function and the object storage. So we're going to create a function, and that function, when invoked, retrieves X minutes worth of tweets, uh, all tweets associated with a certain hashtag. And then it will write a JSON document with those tweets to object storage. And the JSON document will be stored in a bucket on object storage, and it will be available for any consumer who has access. At this point, we don't send emails, we don't insert anything into a NoSQL database, we don't publish to event streaming. That's for later. First, the function and the object storage. As I mentioned before, the functions on Oracle Cloud are implemented based on Project FN. Project FN is an open source framework, the team of which was hired by Oracle about 2 years, maybe 2.5 years ago. It's the container native serverless framework. It implements the serverless functions through Docker containers. So you can basically implement the function in any language you like, in any way you like, because that the implementation will be packaged as a Docker container, and that the Docker container will be the function implementation, and that will be deployed to the Oracle Cloud. And that means that somewhere down there, Docker containers are running, but since this is a completely serverless environment, we don't really know about the Docker containers. We don't know about the number of containers that's running. We certainly don't know where they are running. So these functions can do request handling. Mainly, we'll talk about HTTP requests that they are handling. We'll also use functions that are triggered by events in the Oracle Cloud infrastructure. And then we're not even sure whether it's really an HTTP request or a different type of request, but that's not for us to know. In the HTTP request, there will be a method like put or get or post. There can be headers, there can be query parameters, there can be a URL path, and there can be a body, of course, usually a JSON body, although that's not a requirement. This request is picked up by the FDK, the Function Development Kit, the framework, and this framework will ensure that the request is channeled in the proper way to the Docker container, the running Docker container. That's the implementation of the function that will handle the request. And it will provide the input, or basically the contents of the body from the request, as well as the context. That's all the other stuff from the request. It will make all of that available to the function implementation. The Project FN can run anywhere, can run on your laptop, can run on your company servers, can run on AWS or Azure, and of course it can run on Oracle Cloud. And Oracle Cloud is a provider for FN, and we have native support for deploying functions to Oracle Cloud, as you will see in a moment. Function instance is started, if it's not already running, to handle a request that's intended for that function. And that function, or the container that's implementing the function, will continue to run for 5 to 10 minutes. And if it's not invoked again, it will be removed in order to reduce the usage of physical resources. That's all part of the managed function framework. That's not for us to configure or decide. One function instance can handle multiple requests. So if it has handled a request and it's still in that 5 to 10 minute period, another request comes along, the function instance can handle it as well. In this slide, on the left side, you see the development environment where we create the function implementation using the FN command line interface. And then we use the Oracle Cloud Infrastructure command line interface to invoke a function that we have deployed to the Oracle Cloud. And I will demonstrate this in a moment, so you don't really need to understand this slide right now. We will be using object storage. And object storage is like S3 on AWS. You can store objects, you can store an enormous number of objects, and it's fairly cheap, and it's even cheaper if you store your objects in archive storage. That's for those objects that you don't need rapid access to, as long as you can get access eventually. So object storage is a regional service. It's not tied to a specific data center. It's organized in namespaces and buckets are very similar to folders or directories, if you like. And objects are the files, are the documents. Objects can be very big. Object storage is part of the free tier. And you see a number of other features, and we don't really have time to go into detail. So without further ado, let's go for the first piece of demo, where we will create a function that will retrieve tweets. And for this, I'm going to use Cloud Shell. So hopefully you can follow along. And here we are looking at the Oracle Cloud Console. And I've started the Cloud Shell using, let me remove this. Let me remove this. I've started the Cloud Shell by using this little icon over here. And it's a virtual machine. And in this virtual machine, I have already cloned a repository from GitHub. And in this repository is a simple node application. And this node application is what I'm going to turn into a function. Let's first take a look at what the application can do. I'm going to run it, and this is going to give me an error. I say node run the node runtime, the index.js file, that's my application. And the hashtag that I want it to find tweets for is Zoetermeer, that's the place where I live. And I want it to look back in time for 200 minutes. So that's just over 3 hours. And then it was supposed to write a file, but it didn't because the bucket wasn't found. And that's correct because the bucket doesn't exist yet. Let's create the bucket. Again, I'm in the console. And in this console, I'm going to go to object storage. And in object storage, I can create a new bucket. And this bucket is called tweet reports. And it's important for me for the rest of my demo that I enable the emission of object events, because the event of an object creation in this bucket will trigger a whole bunch of processing. So let's create a bucket. There it is. And at this point, it doesn't contain any objects because it was just created, of course. Now, if I return to the Cloud Shell and run this little application again, it will again tell me that it has processed tweets, 15 tweets, and it has created a file called tweets Zoetermeer with a timestamp. If I now go to object storage and I refresh the page, there's my file. And I can download the file, check details, and I can open the file. And here is a result that's produced by a node application that's running inside Cloud Shell. So it's not really a properly deployed application, but still it's running inside Oracle's cloud infrastructure. And it has produced a file and stored that file on object storage. It's in the cloud, and now I have downloaded it from the cloud back to my laptop. So how to turn this into a function? And for that, I need to get to my own instructions. I'm going to interact with the project FN command line tool. That's going to help me to deploy this code as a function. So I've now logged in into the Oracle Cloud Infrastructure Container Registry, which means that my function can be deployed from my Cloud Shell environment into the cloud proper and be turned into a function that I can then invoke, well, in the regular function way. What I probably should show you at this point is this little meta file. This is where the function is defined. So I'm stating my function is called tweet consumer. The runtime, so the base container that should be used by Project FN is the node runtime. And to run my application, it should execute node, and the name of the application is func.js. And that file, func.js, is shown here. It can be a little bit overwhelming at first, but basically it receives a request. It handles the request, and when it knows what it should do, it will invoke the tweet consumer to produce a tweet report for a specific hashtag and a certain period expressed in minutes. So I'm all set to now get back to the instructions to now deploy my function. So back in Cloud Shell, I'm now instructing Project FN through the command line interface to take my node application, to wrap it as a function into a container, build a container, push the container to the cloud container registry, and register a function based on this container. So if I now go back into the console and I go to developer services and I go to functions, I select an application, and this is the application into which I've just deployed my function. I will see the function over here, tweet consumer, and it was produced well, 30 seconds ago. I can click on the function and I can see the metrics, and the metrics tell me that it has not been invoked, which is understandable because it only is in existence for about a minute. Okay, but now I would like to invoke it. So I go back to my own instructions, and I'm going to invoke the function from the command line. Here we go. So in this case, I'm invoking the function. It's the function tweet consumer in the application called lab1. And I'm passing the body document, which contains cricket as a hashtag and the number of minutes as 3. Now you might wonder, why is this taking so long? And it is taking so long because the function container is started up. It didn't exist yet. And because it's the first invocation of the function, it takes some time. It can be up to 30 seconds, which can be quite long. If I would invoke it again, and I'm not sure why I don't get to see. If I invoke it again, I can just invoke it again. You will find that it completes much more rapidly. Now it was only 2 seconds. When I go to object storage and I refresh, I will now find two documents on Cricket. These were just created from the function this time. So now I have a true cloud native application that's running in this serverless environment. The function is there, I can invoke it, you could invoke it. Well, not quite yet because it's not exposed through an API gateway and it's out there. So now I said you were going to be part of this session. So if I now take the AIOUG webinar hashtag and invoke the function once more, it should be fairly quick. There we go, 2 seconds. Number of tweets processed is 0. Now that's a little bit disappointing. Maybe I should increase the time period from 3 minutes to 30 minutes. And now it has processed 10 tweets. So once again, refresh. There we go. Download, open. And here's the result of your tweeting. There we go. Thank you very much. And I will come back to these tweets, so please keep it up, the tweeting. Okay, now what I did not yet show you is that there's also, well, if we take a look at the metrics, they are not yet available. They will be available before too long. I can also go to the logging service. As I mentioned before, Oracle Cloud Infrastructure provides a logging service, which is very similar to what you can do using the Elastic Stack and using Splunk, for example. And here, all information logged from my application, for example, using console.log in Node application or the systemout.println in Java applications, all that output is collected and can be searched here in the logging console. So the first part of our cloud native application is there. Now we need to add the API gateway to be able to invoke the function just from Postman on my laptop, or from your laptop, by the way, because you could invoke the function in exactly the same way. So what's the API gateway? API gateway is a very lightweight service. It's not the same thing as the API platform that's also available from Oracle. That's fairly heavyweight. Completely different technology stack. Please don't confuse the two. API gateway, it's there to handle HTTP calls. It performs authorization on those calls. It performs routing. It performs mapping of the content from an incoming request to the routed call, and it performs monitoring and auditing. It was launched back in December, so it's still fairly new. It supports at the moment 3 types of backends. So it can route a request to a stock backend, which will return a static mock response, if you like. It's mainly there for testing purposes. It also supports third-party HTTP endpoints or any HTTP endpoint, because that could also be inside Oracle Cloud Infrastructure. And then the one that's most relevant for us today, it supports functions as a backend. So with API Gateway on the public internet, you can publish a URL. When invoked, results in a request being routed to a function. And we'll implement that in a moment. So here are some of the features of the API Gateway. I think I've mentioned most of them. It also performs rate limiting, and it provides injection of course headers, for those of you who are familiar. The authorization is taking place in the following way. A request enters the API gateway. It's supposed to go to a certain backend, but before the request is allowed to go to the backend, the API gateway will invoke an authorizer function. The authorizer function will take a look at the request and will determine whether or not this request is allowed by looking, for example, at basic authentication credentials or tokens in the request. Those are provided, of course, by the service invoker. The JSON that's returned from the authorizer function, like the identity of the invoker of the service, should be embedded in the routed request, but currently is not. And I've been harassing the Oracle team responsible for the API Gateway to add this functionality. Okay. Back to the demo, we're going to add the API Gateway, and more specifically, we're going to add a route in the API Gateway to our function. Well, actually, at the moment, it's my function, of course. So we go to Developer Services, and under Developer Services, there's the API Gateway. I've got one API Gateway set up that's connected to a public subnet in my VCN, my virtual cloud network. That's about the only piece of infrastructure that I need to be aware of. So I'm talking about serverless this, serverless that. That's largely true, except for the gateway. In this gateway, I've got multiple API deployments. That's the term that's used for this. And in my API deployment, I specify routes, and each route describes how a request can be handled. So for example, the existing route stock is of type stock response and will always return this particular body. And I can check that. I can go to Postman, and in Postman I can invoke this stock route, send, and it will return the JSON message, the fixed JSON message, without the curly brace, because of course I just added the curly brace, but I didn't redeploy the API gateway, the API deployment. So I'm going to add a new route. There we go. It's important that my route goes to consume.tweets. I'm going to support both get and put. And of course, I could add other HTTP methods as well. And here I can select the backend type. Like I said, HTTP stock response, or in this case, Oracle function. I'm going to select which Oracle function. It's in the application lab 1, and it's the function that I've just created, tweet consumer. I'm going to save the changes. Now this will take a moment for the API gateway to be taken down and then be reconfigured and refreshed. So at this point, I probably cannot make the call, but before too long, I should be able to, when it gets green, I should be able to make another call. And back to Postman, I can make again the call to the stock backend, and it returns this time with the curly brace. So that's a good sign. And then I can also go to the route consume tweets. That's the one I've just added. And I can specify the hashtag and the minutes. So let's go again, AIOUG web, and let's go back in time for 50 minutes. I'm going to send the request. This time the request is going to, that's disappointing, what, webinar. There we go, 21 tweets have been processed. A file has been generated and has been put on object storage. And now I'm invoking this from the public internet. If you type the same URL and make the same invocation, you will screw up my demo, but you will also get the same effect because there's no IP whitelisting or any type of authorization on our calls. So let's go back to object storage. Let's refresh and let's check whether a new file has been created. There we go. 9:17 UTC. Oh, sorry, that's of course the wrong one. It's this one that you should be interested in. 6.5 kilobytes, 21 tweets. You are doing great. Please keep on tweeting. All right. But we want to have more things happen after this file has been created on object storage. It should result still in records in NoSQL database, in events on streaming, and in emails to my personal email box. So what are we going to do? Well, we're going to add a bunch of new functions. We're going to make use of cloud events. And remember how I've enabled my bucket for emitting events. Those events are cloud events. That's a standard set by the Cloud Native Compute Foundation, of which Oracle is a member. And these events can be routed by Oracle Cloud Infrastructure to several targets. One of these targets is a notification topic, and we're going to have this event published on the notification topic. And from the notification topic, we can have an email target as a subscription. And we can also have a function as a subscription. That's for our next step. So first, we have to specify the event. We have to create the notification topic and the subscription on that topic. So it's easy to get confused a little because the notifications are not the events. On the left side, we see a number of Oracle Cloud Infrastructure services, and all of these services do things. And when these things happen, they can publish cloud events. These cloud events are identified and collected by the event service, and the event service can send them forward, either directly to a function, or to a notification topic, or to a stream. And in today's demo, we're going to take the events and publish them on the notification topic. So they were these two services are very much correlated, although notifications can be used outside of the context of events altogether. So we've got notification topics with subscriptions on those topics. And one of the ways in which we can publish to a notification topic is from a cloud event. The rules determine which cloud events should go to which notification topics. And I will demonstrate this in a moment. So in this particular example, we have a bucket. The bucket publishes a cloud event based on the event rules that specify that when an object is created in the bucket, an event should be published. This results in a cloud event, and that cloud event in this case will be taken to a notification topic. And that notification topic is subscribed to, in our case, by both an email subscription and the function. And we will have the function published to the stream and not have the notification topic directly subscribed by a stream. So we get the event service on the left and the notification service that handles the event on the right. So the new elements in this picture are going to be added in the next set of demo steps. And I hope I'm not confusing myself, or you, of course, because the demo is quite challenging. Here we go to application integration, and now I have to define a notification topic. And this topic is called tweet, there we go, tweet report alerts. And right now it is just a topic. It's a decoupled queue, if you like, and events can be published to the topic and subscriptions can be made on the topic. So let's go to events and let's define a new rule for a new event. Tweet report alert AIOUG. And it's an event that's published by which service? By the object storage service. And the event type from this service I'm interested in is the creation of an object. So whenever an object is created, I want an event to be published. Well, it's not entirely true. I don't want events from just any bucket. I want events only from specific buckets. So here I'm going to specify the bucket name. And only when the bucket name is tweet reports, our specific bucket for tweet reports, should an event be published. And when this event is identified based on these rules, what should happen? Well, we want a notification. We want a notification topic to be notified. And that notification topic is the topic we have just created, the tweet report alerts topic. Create a rule. So now I've set up the flow from the slide, the flow from object storage to events to notifications. But nothing happens yet. So the event is published to the notification topic, but that's where it will end. And of course, we want, let's say for starters, we want an email to be sent. So back to notifications, back to the topic. Now I'm going to add a subscription to the topic. And this subscription is on my personal email address. And I'm not quite sure why a tag fee is mandatory, shouldn't be. Okay, so now the email subscription has been made on this topic. However, it's pending. And it will remain pending until I confirm in Outlook that I indeed want to be subscribed to this notification topic. And there's the email. I have to confirm my subscription. Pay close attention, it's yellow. I confirm. And it should go green any moment now. I'm not sure I actually tried this out in my, there we go, it's green. So at this point, the end-to-end chain is set up completely from object storage all the way to an email. So that means if I go to Postman and I ask for, let's say, 20 minutes worth of tweets and send the request, I hit the API gateway, the function is hit, a document is created on object storage, a cloud event is published, a notification topic is triggered, and an email is sent. And after I've said all of this, I hope that I will have received an email. Not quite yet. No, that's something else. We'll give it a little longer object storage to show that a new file is produced. 925, that's this one, 4.5 kilobytes. There's my email. And what does it say? Well, this basically is the contents of a cloud event. And it tells me that a file has been created, and here's the name of the file. It also tells me, well, actually, here is the name of the file. It tells me it has been created in this compartment. It has been created in this bucket, and it gives me some additional information. And all of this information, well, it's not an ideal email. It's typically information that you will use for automated processing. So this allows me to do processing of the event. Based on the event, I could pick up the file and start working on it. Let's go back to the overview. And our next step is a function that's triggered by this cloud event. In addition to, of course, the email being sent, this function will read the document and it will then create records in a NoSQL database table. Hey, NoSQL database, that's a new cloud service we're adding to the list, trying to get up to 10. The NoSQL database cloud service is fairly new. The underlying technology isn't new at all. It's the Oracle NoSQL database, which you can run on premises. And that itself is based on Berkeley DB as a storage engine. And I'm not quite sure about the origin of Berkeley DB, but it goes back, I think, to the 90s. So it's a fully managed cloud service that's fairly new, but it uses proven mature technology. And it's interesting because it's called NoSQL, but as you will see in a moment, we're using SQL all over the place. So NoSQL really is more tying into the hype than an actual description of what it is. It supports both schemaless JSON, which is very NoSQL-ish, but also SQL and relational data. It supports ACID, for example. That's typically the most important distinction between NoSQL databases and traditional databases. Support for ACID. This NoSQL database supports ACID, but if you don't really need ACID, you can relax a little and you get faster transactions. Are not really transactions then, of course. It supports consistent data. You can see it on the slide. Quite importantly, it supports partial JSON updates. So it can store JSON documents and you can update part of those documents, and those updates are taking place server-side instead of you first having to retrieve the document, change the document, and then put back the entire document, which is a far more expensive operation. It has this nice little feature called time to live, where you can specify for a record that it should automatically destroy itself after a certain period of time. It has built-in data redundancy at the storage level, and it supports multi-region architecture, which basically means it's a global database, which automatically replicates changes across regions. So you will always have low latency access to your data. You can interact with the NoSQL database in various ways, using REST APIs, the command line interface, and various SDKs. And for this demo, we will be using the Node SDK. For local development and testing, you could use the NoSQL Database Cloud Simulator, which is installed locally, and then, as the name indicates, it simulates the database cloud service. So, back to our demo. And what did I prepare? I'm going to show you in the console the NoSQL database service. And most importantly, I'm going to show you that there are no tables at this point. Then in Cloud Shell, I'm going to create a table. And the statement for this is hidden somewhere in these instructions. There we go. So I'm going to create a table with this statement. And the table is called tweets table. There we go. A work request has been accepted, and in an asynchronous job, this table is currently being created. And if I refresh this page, I think by now the table probably should be there. So hopefully there is a table. There we go, a tweets table. And the tweets table has the following columns: ID, text, author, tweet, timestamp, language, and the hashtags. And it currently does not contain any records. And you will notice that the statement used to find out whether there are any records in this NoSQL database is very much a SQL statement. And as you know, NoSQL really stands for not only SQL. There's more to life than SQL. Oh yeah, really is there. So now I'm going to create a function that can be triggered by the notification, and that will then create a record in a NoSQL database. So now I'm going to bore you a little bit. We are going to a Katacoda environment, and Katacoda is a very interesting platform for doing tutorials and also for running demos like this one. And the main reason why I'm not in Cloud Shell right now is that Cloud Shell unfortunately has an older version of the Node runtime, which I cannot use for this particular demo. So I will have to set up my environment. In this Katacoda environment, I have a browser-based version. I will have a browser-based version of Visual Studio Code. I will hide this mark. Unfortunately, this will take a little while. And I was hoping to not have to do this, but this environment lives for less than an hour, which is not enough for this particular demo. So I have to copy the key. And this is something that you will find yourself doing over and over again if you're going to work against the cloud, unless you're in the Cloud Shell, because in the Cloud Shell, all of this information is already available. So let's check whether my connection has been set up. I'm going to use the Oracle Cloud Command Line Interface. I'm going to ask for a namespace, and indeed it can find the cloud tenancy. And there are a few more files that I need to edit. This is not what you would normally have to do. This is only for because of the way how I have configured my my demonstration. So that's on me. And unfortunately, it's also a little bit on you, of course. Almost there, almost there. Copy the key. Copy the OCI config. This is not information I'd like to include in GitHub. Of course, if you go to a recording of the session, you could probably screen scrape it if you are really anxious to get into my trial account. I think these are all the files I need. Then we're going to set up fn in order to be able to create a function. And almost there. Finally, log into the container registry. Same thing you saw me do in Cloud Shell. And finally, my authorization token paste and login successful. Now we are in business. So now I'm going to go to the code for my tweet report processor. And I'm going to the installation of the NPM modules that are in support that are part of my application. It's basically the code that's in here, and of course I will make a link available to the GitHub repository with all this code. Here in this line, the tweet document is retrieved from the object storage from the bucket using the file name that we've learned from the cloud event. It's parsed, and then it will be persisted to NoSQL. Now, we don't have time to go into this in detail, but basically I'm performing through the Node SDK for the NoSQL database, I'm performing put operations that create JSON records or that specify JSON records that are turned into relational records in the NoSQL table. I will do that in a moment. And I can run this with node index.js and then the name of an actual file on the object storage. So let's go to object storage. Let's go to tweet reports. Let's take one of the AIOG webinar files. Let's paste it. Okay, if everything is okay, when I run this application, records are created in the NoSQL table. So at this moment, no records. And now hopefully, 14 records should have been taken from the file and should now be in this NoSQL database. There we go. And there they are. A very interesting demonstration. That's good to hear. And a live Twitter demo. Yes, that's true. And it was a nice short demo. Well, actually, it's a fairly long demo, isn't it? Okay, so this is working. And one thing I now need to do is to turn this into a function. So I'm going to deploy it. And we see the same steps as before. So a new Docker image is built. This Docker image is pushed to the cloud registry, and then it will be registered as a function. It's almost there, almost there, almost there. And then I need to invoke it, of course. Do my demo steps. So I can invoke it using this statement, except for the fact that this file doesn't exist. So I need to copy this and change the name of the file. Back to object storage. Let's take another one. So instead of running the Node application locally, well, locally here in my Katacoda environment as I did before, and I'm going to invoke the function on OCI. This will take a while because the function first needs to be started, or the Docker container image needs to be started. And when the instance is running, it will read, and then it will create 26 records in the NoSQL database. Regarding Cricket. Sorry, there we go. So you'll see a number of tweets regarding Cricket. So what should happen now if I go to Postman, and maybe I'll skip that for the moment. If I would go to Postman and run this again, at this point, a new document will be generated into object storage. This will fire the cloud event. This will trigger the function, and the function will write NoSQL database records. Let's not dwell on this, but let's go on to look at streaming. So that's the last piece of the puzzle. Each tweet should be published to a stream. So the OCI streaming service, if you know what Apache Kafka is, you understand what the streaming service is all about. It's Kafka-like. It's an event queue. It has support for partitions and consumer groups, but I'm not going to discuss details about that for the moment. Events can be published through a REST API. There's also a Java SDK, which of course makes use of the REST API, and you can use it in a Kafka-compliant manner. So messages are published by publishers and they are consumed by listeners. They are not pushed to the consumers. You have to actively retrieve them. So you make a REST call to ask, are there any more messages from me as a consumer, as a listener? This listener can be anywhere, can be on premises, can be in a third-party cloud, can be inside Oracle Cloud Infrastructure. Message retrieval is done through something which is called a cursor object. That's very similar to a long-running query. This cursor object remembers what's the last message you have already retrieved and determines from there which next set of messages should be handed to you. Let's just go do it. The messages are retained on a stream topic for a maximum of 7 days. And I think at this moment you cannot extend this. And there's some details about the maximum throughput. It's fairly high. So streaming is really intended for high volumes of messages, not just for your service to service, microservice to microservice interaction. You could use it for this, but it's a bit overkill. Maximum message size 1 megabyte, which is of course fairly high. So we saw this slide before, but now I'm focusing on streaming. So events, cloud events can be put on streaming right away. But then you get as an event on streaming, you will get the same content that we saw in the email, which is very technical and which is not interpreted at all. So in this example, we're going to take a cloud event, put it on notification, and the notification topic triggers a function, and the function will publish a refined event on the streaming topic. So that's what I'm going to show you as a last but one step in our demo. I'm going to go to analytics, and under analytics, there is streaming. I've currently set up a stream. It's the lab stream. And I could show you how to produce a test message and the test. Maybe I should show you how to create the test message. At this moment, there are no messages on the stream, or at least no recent messages from the last minute. Produce a test message. Hello. That's not even hello. Produce. It says success. Let's see if it's there. It is here. Okay. So the stream's there. I can produce to it, and this console at least can consume from it. I'm going to go back to this environment. And in my function, I have currently disabled the publishing to the stream. Now it's enabled. Of course, it's only enabled in the source code. I haven't yet redeployed it as a function. And the actual code for this is over here. Here, basically, I'm looping over all the tweets in the document, and every tweet is published to this stream ID. That's what's happening here. We don't have time to go into details, but here's the code. So you can see it's not trivial, but it's also not huge. Going back to the terminal, and I'm going to deploy my function again. So I'm taking the node application with this small change. Now it's also capable of publishing to a stream. It's preparing the image. It will push the image. It will register a new version of the function. And now we're done. So I could invoke the function locally, but of course the function is already triggered. If I invoke the function that creates the tweet report, publish it to the object storage, it will trigger the cloud event, that will trigger the notification, that will trigger the function, that will publish the streams. So let's just click on this URL, and this URL looks at, well, maybe that's not the hashtag I should be using. Let's change this one to webinar, enter it again. It has processed 47 tweets, and all these tweets should have been published to the stream. Let's go. If I press load messages, I hope there will be 47 additional messages. This is not good. This is not good. Why not? Why not? In my ear, I hear a new file arriving, so maybe So at this point, I would normally resort to the logging service to see why I do not get my events. I don't think we have time for a full problem analysis. And I'm quite sure you're not interested in that full analysis. Let's try one last time. No, no items found. Of course, this morning this was still working, and I'm not sure what I have done wrong to upset it. So the function, in addition to publishing direct to the NoSQL database, should now also have published each tweet to a stream. And unfortunately, it doesn't do so. At this point, functions on OCI cannot be scheduled. So you can invoke them, you can trigger them, but you cannot schedule them. However, there is this workaround. You can use something that's called a monitoring health check to perform URL requests, HTTP requests on a schedule. That schedule is intended to regularly check on the health of certain endpoints. But of course, you can also check. You can also use it for invoking those endpoints on a desired schedule. So it's part of the monitoring service, and the monitoring service is also about collecting metrics, exploring metrics, analyzing metrics, and defining alarms on those metrics. So the health checks are defined through the eyes of an external consumer. In fact, when you define a health check, you have to specify where it should be running, whether it should be running on AWS in a certain region. So you can check if from that region, your service is still accessible. It's very convenient. It can do just pings or HTTP calls. You can specify the headers, you can specify the time interval, and you can, as I said, specify from where the check should take place. You can inspect the results in the console, and you can use it to trigger a function on a time schedule, as I said. So that's the last part of the puzzle. Allow me one last check for my, nah, I just have to let it go. So in summary, I'm just showing you an overview of everything we have been talking about and have been implementing in the last 55 minutes. A function that reads tweets, consumes tweets through the Twitter API, stores a report of the tweets in object storage, which triggers an event, which is published to a notification topic, which triggers sending of an email and triggers execution of a second function, a function that reads from object storage, the document, that creates NoSQL records, that should have created streaming messages. I will get back to that in some way. We've seen the logging service to see what's going on and analyze problems. I've mentioned the monitoring, and I've discussed the API gateway to get to our function from the public internet or from a health check, which we can use to schedule the function. You have not seen me interacting with infrastructure, maybe storage if you like. I've mentioned the virtual cloud network. We have not discussed compute at all. And of course, this is running on compute. It's not my compute, and it's scalable, so I don't really care. It's cloud native. That was the focus of this presentation. So I would like to thank you for your attention, and I really hope this was useful, and I hope we will meet again in the Oracle Groundbreakers Yatra that's going to take place fairly soon. With that, thank you very much.
Thank you, Lucas. So please stay so that you can enjoy the exam time now for audience.
Sure,
Let me
I
share
will be
my
here.
screen. Share my screen. Okay, so hope you can see my screen, right?
Yeah.
Okay,
Yeah,
thank you.
again.
Yeah, because when you have a multiple screen, so just want to make sure you're showing the right screen. Thank you, Lucas, for your time. We really enjoyed. Actually, I was really, keen to see all this tweets progressing from, going from everywhere. And, we were thinking of doing the same thing for, especially for AOG. And we thought of collecting these tweets during Oracle Groundbreaker Yatra. Anyway, thanks for that. And this is really helpful for us for learning. As suggested earlier, please use hashtags, and Lucas' Twitter ID is Lucas Jalema, and you can thank him by tweeting or posting in Facebook, whatever you like. Now the exam time. So let me quickly get the exam running. And most of you guys know you need to go to menti.com, and today's code is 455625. I'll wait for 2 minutes. So please join this menti.com. People are joining. Let's wait. Go to menti.com, use the code 455625. And you know how this works, right? So you need to answer. There are 6 questions, and whoever answers first, they will get more points. It's not the right answers. Yes, absolutely, you need to answer right answers, but it also calculates how quickly you press the right answers, right? So I think the user interface, you can use mobile devices for really good user experience. Also, you can use a web portal. Um, let's wait for at least I get 20 people so that we can run the quiz. Get one more, last bone. Oh, thank you. So let's get started. I'm not going to read the question, so please read. Okay, super. 17 people answered the right answer. So let's see the leaderboard. Pooja is leading the board, and she did actually fastest answer, right? Let's go to the next question. Oh no. Only 3 people answered right question, so that means you guys need to focus a little more. Anyway, thanks for all 3 people answer. Let's see who's in leaders board. Okay, these are the 3 people: Prakash, Harjul, and Vinod. Oh, Harjul is the fastest. Let's go to the next question now. Yeah, this is very important, right? So all others answered wrong question is a wrong answer. So please understand this is like 1 OCPU and 20 GB data each. That's more important. Leaderboard. Pooja, she's the fastest, but still Harjul is the leading. Next question. Superb. And I think there's a confusion between Oracle functions and project functions. So anyway, let's see who's in leaderboard. Prakash is coming. No. Okay. So the last, let's see the leaderboard. Priyank. Super. Wow, this is what happens in the last minute. But trust me, there's a last question, and just a clue that it's a multiple answer question. Okay, basically you can take multiple answers. So we just want to make sure everybody wins at the last question. Okay, so who's the winner today? Prakash. Congratulations, Prakash. And so we'll reach out to you for passing the gift voucher. And thanks for participating. So let me go back to my slides.
If anyone is interested in why the demo failed, I never created a subscription on the notification topic for the function. So the email is sent, but the function isn't triggered. Really stupid.
No, that's really great insights, Lucas. I think definitely we learned so much today. Um, so again, I just want to end this session with, from next Wednesday onwards, it's like going to be crazy week for us, especially for all my team members working for last 1 month, sleepless nights. And, you trust me, it's like we are running, like we are sleeping only 4 hours to do all this program, scheduling, selecting speakers, and the website, so many challenges. Okay, I think now we are in good shape, so now we need your support. Participate. There are plenty of knowledge, and this year, like since it's online, we are bringing speakers around the world, and also we have actually scheduled 2 more days pending on Saturdays. Saturdays we want to bring more of is community keynotes, interviews, so fireside chats. So it's going to happen a lot of things from next week onwards. You know, since also divided these dates into track wise, as you can see, the day one is a database DBA track, developer track, apps track. And since we have more DBS or in our community, so we are running DBA track for almost 4 times. So please participate, register. It's easy. Go to AOG website, sign up for a free registration, and come to OG Yatra page and register, right? And join, and also pass this information to across the globe. It's not limited to India, because we are running from morning 10 o'clock to evening 10 o'clock. So it's a non-stop learning. Please support us, join us, and that way we can share the knowledge. And with that, a big thanks to Lucas, and he's actually supporting us for a long time. And thanks, Lucas, and hopefully we'll see you very soon
I
in
hope so.
Yatra.
Yeah,
Thank
that would
you.
be nice. Thank you.
Thank you. Thank you very much.